Namaskara. Dear students, till here in electric charges and fields, we have learnt about the Coulomb's law of electrostatics. Thereafter, the force due to multiple charges. Then electric field due to multiple charges. Then the representation of electric field with the electric field lines. Then we have learnt about the electric flux. Today we are going to learn one of the very important concepts in electrostatics. Thereafter we are going to learn two very important derivations. Let's see what is the important concept. In electrostatics we are having a concept of electric dipole. Let's see what is meant by electric dipole. Electric dipole is a system of two charges. One is positive charge, another is negative charge. That is two opposite charges with same magnitude, two equivalent opposite charges, and they are being separated by a small distance 2a. The 2a is a small distance. It's order of 10 power minus 5 minus 6 minus 10 meters maybe. It's a very small distance. Then this system we call it as electric dipole. An electric dipole is a system of a pair of equal and opposite charges plus q and minus q separated by a small distance 2a. In electric dipole we are going to have some very important concepts. Let's try to recall them. If I find the midpoint between the ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಅಂಡ್ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್, ಈ ಎರಡು ಚಾರ್ಜ್ಗಳ ನಡುವೆ ಮಿಡ್ ಪಾಯಿಂಟ್ ಎಲ್ಲಿದೆ ಅಂತ ಹುಡುಕ್ತೀನಿ. ಇಫ್ ಐ ಗಾಟ್ ದಟ್ ಮಿಡ್ ಪಾಯಿಂಟ್, ಈ ಮಿಡ್ ಪಾಯಿಂಟ್ ಅನ್ನ ವಿ ಕಾಲ್ ಇಟ್ ಆಸ್ ಸೆಂಟರ್ ಆಫ್ ದ ಡೈಪೋಲ್. ಡೈಪೋಲಿನ ಸೆಂಟರ್ ಅಂತ ಕರಿತೀವಿ. ದೆನ್ ಎ ಲೈನ್ ಪಾಸಿಂಗ್ ಥ್ರೂ ದ ಟೂ ಚಾರ್ಜಸ್ ಅಂಡ್ ದ ಸೆಂಟರ್ ಆಫ್ ದ ಡೈಪೋಲ್. If I take a line passing through the two charges and center of the dipole, then that line we term it as axis of the dipole. Dipole in the aksha axis anta karitive. Thereafter, if I have a line passing perpendicular to the axis through the center of the dipole, I am having a line which is passing through the center of the dipole and perpendicular to the axis of the dipole. This line I will call it as equatorial line of the dipole. Then in dipole we are having one more very important concept called as dipole moment. The dipole moment is the product of the charge and the distance between the charge. It is the product of the either charge and the distance between the charge. It is given by charge into distance between the charges. P is equal to Q into 2a. That is P is equal to 2aq. And this dipole moment is very important. It's a vector quantity. This is very important. Dipole moment is a vector quantity. Since it's a vector quantity, we have to define its direction. Then the direction of a dipole moment is always directed from negative charge to the positive charge. Minus q ನಿಂದ ಪ್ಲಸ್ q ಕಡೆ ಇರುತ್ತೆ. ಯಾವಾಗಲೂ ಡೈಪೋಲ್ ಮೊಮೆಂಟ್ p ಮೈನಸ್ q ನಿಂದ plus q ಕಡೆಗೆ ಡೈರೆಕ್ಟ್ ಆಗಿರುತ್ತೆ. This is the direction of dipole moment. Very important. Then what is the SI unit of dipole moment? We have learned charge into distance. Charge is having the SI unit coulomb and the distance is meter, and the SI unit of dipole moment is coulomb meter. See here we are representing capital C. If we make it as small c, it becomes centimeter. If I am having capital C, it is coulomb meter is the SI unit of dipole moment. Then what is the dimensional formula of dipole moment? Charge into distance, distance L power 1, charge T power 1, A power 1. Therefore the dimensional formula of dipole moment is L power 1, T power 1 into A power 1. Dear students, till here we have learnt about the electric field due to a point charge. The electric field due to a point charge is given by E is equal to 1 by 4 pi epsilon naught Q by R square into R cap. R cap gives the direction of the electric field due to a point charge. ಏನಾದರೂ ಈ ಚಾರ್ಜ್ ಪಾಸಿಟಿವ್ ಆಗಿದ್ರೆ it is radially outwards, direction is radially outwards. ಈ ಚಾರ್ಜ್ ನೆಗೆಟಿವ್ ಆಗಿದ್ರೆ direction is radially inwards. ಇದನ್ನು ನಾವು ಹಿಂದಿನ ಸೆಷನ್ ಅಲ್ಲಿ ಅಭ್ಯಾಸ ಮಾಡಿದ್ದೀವಿ. Today let's try to calculate the electric field due to a dipole. ಡೈಪೋಲ್ ಇಂದ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಅನ್ನು ಕಂಡುಹಿಡಿಯುವಾಗ ಆ ಯಾವ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಕಂಡುಹಿಡಿಯಬೇಕಾಗಿದೆಯೋ ಆ ಪಾಯಿಂಟ್ ಎಲ್ಲಿದೆ ಅನ್ನೋದು ಮುಖ್ಯ. ಎಲ್ಲಿದೆ ಅಂದ್ರೆ ವೆದರ್ ದ ಪಾಯಿಂಟ್ ಈಸ್ ಆನ್ ದ ಆಕ್ಸಿಸ್ ಆಫ್ ದ ಡೈಪೋಲ್. ಡೈಪೋಲಿನ ಆಕ್ಸಿಸ್ ಮೇಲಿದೆಯಾ? ಡೈಪೋಲ್ ಮೇಲಿನ ಆಕ್ಸಿಸ್ ಮೇಲಿದ್ರೆ ಅದಕ್ಕೆ ಸಪರೇಟ್ ಫಾರ್ಮುಲಾ ಬರುತ್ತೆ. ಅದೇನಾದ್ರು ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಕಂಡುಹಿಡಿತಾ ಇರುವಂತಹ ಪಾಯಿಂಟ್ ಈಕ್ವಿಟೋರಿಯಲ್ ಲೈನ್ ಮೇಲೆ ಇದೆಯಾ? then the formula for the electric field is different. Now we are going to derive an expression for electric field at a point on the axis of a dipole. Adu one derivation, very important, 5 marks derivation. And the second one is electric field due to a dipole on the point on the equatorial line. This is also a 5 marks derivation, one of the very important derivation. Let's try to have those derivations one after another. Now let's see the first derivation. Now let's derive an expression for electric field at a point on the axis of an electric dipole. ಒಂದು electric dipole ಇನ ಆಕ್ಸಿಸ್ ನ ಮೇಲೆ ಒಂದು ಪಾಯಿಂಟ್ ಇದೆ. ಆ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಎಷ್ಟಿದೆ ಅಂತ ಕಂಡುಹಿಡಿಯೋಣ. For that let's consider a dipole. ಒಂದು ಡೈಪೋಲ್ ಅನ್ನು ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ದೀವಿ. ಡೈಪೋಲ್ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ದೀವಿ ಅಂದ್ರೆ ಅರ್ಥ it is having two equal and opposite charges plus q and minus q separated by a distance 2a. ಇಲ್ಲಿ ಸೆಂಟರ್ ನ ತೋರಿಸಿ, ಸೆಂಟರ್ ನ ಈಚೆ a, ಈ ಕಡೆ ರೈಟ್ ಗೆ ಲೆಫ್ಟ್ ಗೆ ತೋರಿಸಿನಿ. a plus a, 2a is the length of the dipole and p is the dipole moment. It is directed from minus q to plus q. ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್ ಆಗಿ ಅಬ್ಸರ್ವ್ ಮಾಡಬೇಕು. the dipole moment is directed from minus q to plus q. This is the dipole we have considered. ಈಗ ಈ ಡೈಪೋಲಿನ ಆಕ್ಸಿಸ್ ಮೇಲೆ ಒಂದು ಪಾಯಿಂಟ್ ಇದೆ x ಅಂತ. ಈ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ನಾವು ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಡ್ಯೂ ಟು ದ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಅಂಡ್ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್, ವಾಟ್ ಇಸ್ ದ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ electric field is there, we are going to calculate. ಹಾಗೆ ಈ ಪಾಯಿಂಟ್ x ಎಲ್ಲಿದೆ? this point x is at a distance of r from the center of the dipole. ಡೈಪೋಲಿನ ಸೆಂಟರ್ ಇಂದ r ಅಷ್ಟು ದೂರದಲ್ಲಿ ಈ ಪಾಯಿಂಟ್ x ಇದೆ. Then let's calculate the electric field at the point x due to the dipole. ಡೈಪೋಲ್ ಅನ್ನ ಒಂದೇ ಸತಿ ಪ್ಲಸ್ ಕ್ಯೂ ಮೈನಸ್ ಕ್ಯೂ ತಗೊಳಕ್ಕಾಗಲ್ಲ. ಲೆಟ್ಸ್ ಫೈಂಡ್ ದ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಡ್ಯೂ ಟು ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಅಂಡ್ ದೇರ್ ಆಫ್ಟರ್ ದ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಡ್ಯೂ ಟು ನೆಗೆಟಿವ್ ಚಾರ್ಜ್. ಫಸ್ಟ್, ವಾಟ್ ಈಸ್ ದ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಡ್ಯೂ ಟು ದ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಅಟ್ ದ ಪಾಯಿಂಟ್ ಎಕ್ಸ್? ಇಟ್ ಈಸ್ ಇ ಪ್ಲಸ್ ಕ್ಯೂ. ಡ್ಯೂ ಟು ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ದ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಇಸ್ ಆಲ್ವೇಸ್ ರೇಡಿಯಲಿ ಔಟ್ವರ್ಡ್ಸ್ ಅಂತ ಕರೆದಿದ್ದೀವಿ. ದೂರ ಹೋಗುವಂತ ದಿಕ್ಕಲ್ಲಿರುತ್ತೆ. therefore the electric field E plus Q due to the positive charge is in this direction. ಹಾಗಿದ್ರೆ ಇದರ ವ್ಯಾಲ್ಯೂ ಎಷ್ಟಿರುತ್ತೆ? the value of this is 1 by 4 pi epsilon naught Q by, see the distance between plus Q and X is R minus A. ನೋಡಿ, ಇಲ್ಲಿಂದ ಇಲ್ಲಿ ತನಕ ಬೇಕು ಡಿಸ್ಟೆನ್ಸ್. this distance is r minus a whole square. Then the direction of this electric field is along the dipole moment. Dipole moment in a dikku ಮತ್ತೆ electric field in a dikku same ಇದೆ, E plus Q. Then what is the electric field due to the negative charge? minus Q in the electric field ಎಷ್ಟಿದೆ? due to the negative charge the electric field is always radially inwards ಅಂತ ಓದಿದೀವಿ. therefore the electric field is directed towards the negative charge. This electric field E minus Q is given by 1 by 4 pi epsilon naught Q by, ಇವಾಗ ನೋಡಿ ಡಿಸ್ಟೆನ್ಸ್ ಸ್ಕ್ವೇರ್ ಏನಾಯ್ತು? ಫ್ರಮ್ ಸೆಂಟರ್ ಟು ದ ಪಾಯಿಂಟ್ ಎಕ್ಸ್ ಇಸ್ ದ ಡಿಸ್ಟೆನ್ಸ್ ಆರ್. ಸೆಂಟರ್ ನಿಂದ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಎಷ್ಟು ದೂರ ಇದೆ? ಎ ಅಷ್ಟು ದೂರದಲ್ಲಿದೆ. ದೆನ್ ವಾಟ್ ಇಸ್ ದ ಟೋಟಲ್ ಡಿಸ್ಟೆನ್ಸ್ ಬಿಟ್ವೀನ್ ದ ಪಾಯಿಂಟ್ ಅಂಡ್ ದ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್? ಆರ್ ಪ್ಲಸ್ ಎ. therefore the total distance is r plus a whole square. Then the electric charge due to, then the electric field due to the negative charge minus q. E minus q is given by 1 by 4 pi epsilon naught q by r plus a whole square. The direction of E minus q is opposite to the dipole moment. E minus q ಮತ್ತೆ dipole moment ಪರಸ್ಪರ ವಿರುದ್ಧ ದಿಕ್ಕಲ್ಲಿದ್ದಾರೆ. It is opposite to dipole moment. Then what is the total electric field at the point x? Point x ಅಲ್ಲಿ total electric field ಎಷ್ಟಿದೆ? Due to E plus q and due to E minus q, then the total electric field is calculated by both are vector quantity. It can be calculated by the vector addition of E plus q and E minus q. Then what is the vector addition of E plus q and E minus q? To find the vector addition, we have to make use of the vectorial representation resultant of two vectors. Here we can observe E plus q and E minus q both are in opposite direction. Then what is the angle between E plus q and E minus q? It is 180 degree. If the angle is 180 degree, the two vectors are opposite, then what is the resultant between the two vectors? If we know that resultant is equal to vector A plus vector B, resultant magnitude is given by square root of A square plus B square plus 2AB cos theta. If theta is 180 degree, then cos theta becomes minus 1. Then square root of A square plus B square minus 2AB, it is nothing but A minus B whole square, square root vanishes. Then the resultant is A minus B. Hence here also E plus Q and E minus Q are in opposite direction. Theta is 180 degree, then the net electric field is E plus Q minus E minus Q. Now what is the direction of the resultant field? Resultant field ನ ಡೈರೆಕ್ಷನ್ ನೋಡಬೇಕಂದ್ರೆ ನೋಡಿ x ಪಾಯಿಂಟ್ ಪ್ಲಸ್ q ನಿಂದ ಹತ್ರ ಇದೆ, ಈ x ಪಾಯಿಂಟ್ ಮೈನಸ್ q ನಿಂದ ದೂರ ಇದೆ. ದೂರ ಇರೋದ್ರಿಂದ E ಮೈನಸ್ q ಕಡಿಮೆ ಇರುತ್ತೆ, ಪ್ಲಸ್ q ಹತ್ರ ಇರೋದ್ರಿಂದ E ಪ್ಲಸ್ q ಜಾಸ್ತಿ ಇರುತ್ತೆ. Since E plus q is more than E minus q, the net value is along the direction of E plus q. The resultant field is along the direction of E plus q. Hence, this is in the direction of the dipole moment. The net electric field is along the direction of dipole moment because E plus q is more compared to E minus q. Then let's calculate the total electric field. The total electric field, to calculate total electric field, substitute the value of E plus q and E minus q. It is 1 by 4 pi epsilon naught q by r minus a whole square minus E minus q is 1 by 4 pi epsilon naught q by r plus a whole square. Now take the common factor. What are the common factors here? 1 by 4 pi epsilon naught and q is the common factor. Take the common factor. Then we are left with 1 by r minus a square minus 1 by r plus a whole square. Now we have to take the LCM and we have to do the fraction. We have learned a by b plus r minus c by d is equal to, what is the LCM? D into d, the numerator, a into d plus r minus b into c. Make use of this method. Then the sum of the fraction, the difference of the fraction is LCM is r minus a square into r plus a square. In the numerator we will have r plus a square minus r minus a square. Now take the, you make use of the identities a plus b whole square and a minus b whole square. In the denominator take the square as common. In the denominator we are taking the square as common. In the numerator make use of the identity r square plus a square plus 2ra and keep the minus as it is. Within the brackets expand the a minus b whole square. You make use of the a minus b whole square formula. R square plus a square minus 2ra. Now remove the brackets. Brackets ತೆಗಿರಿ. ತೆಗೆದಾಗ minus into plus minus ಆಯಿತು, minus into plus minus, minus into minus plus. Now plus r square minus r square vanishes, plus a square minus a square vanishes. Then we are left with plus 2ra and plus 2ra. It will become 4ra. Therefore E is equal to q by 4 pi epsilon naught 4ra divided by r square minus a square. ಇಲ್ಲಿ ನಾವು r square minus r minus a into r plus a whole square ಇದೆ, a plus b into a minus b formula ಇದೆ. Then it is in the form of a square minus b square. Now if we take R is much greater than A. R ಬೆಲೆ ತುಂಬಾ ಜಾಸ್ತಿ ಇದೆ A ಗಿಂತ. ಆವಾಗ ಸ್ಕ್ವೇರ್ ಮಾಡಿದಾಗ ಸಣ್ಣ ವ್ಯಾಲ್ಯೂನ ಸ್ಕ್ವೇರ್, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ನಾನು 0.01 ಅಂತ ತಗೊಂತೀನಿ, ಸ್ಕ್ವೇರ್ ಮಾಡಿ 0.01 ಸ್ಕ್ವೇರ್ ಮಾಡಿದಾಗ 0.0001 ಆಗುತ್ತೆ. ಅಂದ್ರೆ ಸ್ಕ್ವೇರ್ ಮಾಡಿದಾಗ ಸಣ್ಣ ವ್ಯಾಲ್ಯೂ ಇನ್ನೂ ಸಣ್ಣದಾಗತ್ತೆ, ದೊಡ್ಡ ವ್ಯಾಲ್ಯೂ ಇನ್ನೂ ದೊಡ್ಡದಾಗತ್ತೆ. ಆ ಕಾರಣದಿಂದ ಎ ಸ್ಕ್ವೇರ್ ಅನ್ನು ನಾವು ನೆಗ್ಲೆಕ್ಟ್ ಮಾಡ್ತೀವಿ. ಹಿಯರ್ ವಿ ನೆಗ್ಲೆಕ್ಟ್ ಎ ಸ್ಕ್ವೇರ್ ಬಿಕಾಸ್ ಎ is much less than r. On neglecting a square it will become 4ra by r power 4, r square whole square r power 4 ಆಗುತ್ತೆ. 1r vanishes. Then we are left with 4, 2 into 2 4 qa divided by r cube. Now in this equation, what is 2aq? We have learned that 2aq is the dipole moment of a dipole. Therefore, replace 2aq with a p. Then net electric field is 1 by 4 pi epsilon naught 2p by r cube along the direction of the dipole. ನಾವು ಪ್ರಾರಂಭದಲ್ಲಿ ನೋಡ್ಕೊಂಡ್ವಿ, along the direction of dipole moment. Hence, the electric field due to a dipole on the point on the axis along the is always along the dipole moment. This is one of the very important derivation. ಬಹಳಷ್ಟು ಬಾರಿ ಪರೀಕ್ಷೆಗಳಲ್ಲಿ ಕೇಳಿರುವಂತ ಒಂದು 5 ಮಾರ್ಕ್ಸಿನ derivation ಇದು. Now, let's have one more important derivation. Let's try to obtain an expression for electric field at a point on the equatorial line of an electric dipole. Electric dipole in a equatorial line ಮೇಲಿರುವಂತ electric field ಅನ್ನು ಕಂಡುಹಿಡಿಯೋಣ. For that, let's consider a dipole. ಒಂದು dipole ಅನ್ನು consider ಮಾಡೋಣ. Dipole consider ಮಾಡಿದ್ರೆ dipole ಅಲ್ಲಿ ಏನೇನಿದೆ? We are having a positive charge plus q and minus q, a pair of equal and opposite charges separated by a distance a plus a 2a, and there is a dipole moment. This dipole moment is always directed from minus charge to plus charge. Minus q in the plus q irutte dipole moment. Now we need a point on the equatorial line of a dipole. Dipole in the equatorial line mele ಒಂದು point ತಗೊಂಡಿನಿ x ಅಂತ. It is at a distance r. Now I have to calculate what is the electric field at this point due to the positive charge and negative charge. Plus q ಮತ್ತೆ minus q ನಿಂದಾಗಿ ಈ x ಪಾಯಿಂಟ್ ಅಲ್ಲಿ electric field ಎಷ್ಟಿದೆ ಅಂತ ನಾವು ಕಂಡುಹಿಡಿಯಬೇಕಾಗಿದೆ. Now to find the electric field, we need the distance between the x and the positive charge and distance between x and the negative charge. As we have defined, equatorial line is the perpendicular line passing through the midpoint. Perpendicular line passing through the midpoint adaga, now we can able to have a right angle triangle. Therefore, using Pythagoras theorem, the distance of point x from the positive charge is square root of r square plus a square, and similarly the distance between the negative charge and the point x is r square minus a square. Then what is the electric field due to the positive charge plus q at x? The electric field will be in the same direction radially outwards along that line joining x and the charge e plus q. Then what is the value of e plus q? The value of the electric field due to the positive charge is given by 1 by 4 pi epsilon naught q by, what is the distance? Square root of r square plus a square whole square. This is the electric field. What is the direction? Radially outwards. Then what about the electric field due to the negative charge? If I cancel the square root, this equation reduces to the form 1 by 4 pi epsilon naught q by r square plus a square. Then what is the electric field due to the negative charge? The electric field due to the negative charge is radially inwards. It is e minus q. ಇಲ್ಲೊಂದು ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಇಟ್ಟರೆ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಅಟ್ರಾಕ್ಟ್ ಮಾಡೋದ್ರಿಂದ ರೇಡಿಯಲಿ ಇನ್ವರ್ಡ್ಸ್, ಇಲ್ಲಿ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಇದ್ರೆ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ರಿಪಲ್ ಮಾಡೋದ್ರಿಂದ ರೇಡಿಯಲಿ ಔಟ್ವರ್ಡ್ಸ್. ಇದು ವ್ಯತ್ಯಾಸ ಗೊತ್ತಿರಬೇಕು. Therefore, the electric field due to negative charge is radially inwards. ಹಾಗಿದ್ರೆ ಇದರ ಬೆಲೆ ಎಷ್ಟಿದೆ? What is the value of E minus Q? The value of the value of the electric field due to the negative charge minus Q. Then the value of electric field due to the negative charge minus Q at x is given by E minus Q is equal to 1 by 4 pi epsilon naught Q by square root of distance is a square root of r square plus a square whole square. Square root vanishes. Then the electric field due to negative charge is 1 by 4 pi epsilon naught Q by r square plus a square. Now we have to find the net electric field at the point x due to the two charges. Therefore, we have to take the vector summation of these two charges, these two electric field E plus Q and E minus Q. Then let's find the net electric field due to the dipole. Now, to find the net electric field, let's resolve E plus Q into its horizontal component and normal component. Vector resolution ನಾವು ಓದಿದೀವಿ. ಒಂದು ವೆಕ್ಟರ್ ಅನ್ನ ನಾವು ರೆಸಾಲ್ವ್ ಮಾಡಿದಾಗ E plus horizontal x component ಮತ್ತೆ y component ಆಗಿ split ಆಗುತ್ತೆ. Then what are the x component and y component of E plus Q? Now, if I take the angle made by the dipole with the line joining the charge is theta, then with the horizontal its value will become theta, then the horizontal component is E plus Q cos theta and the vertical component is E plus Q sin theta. E plus Q ಅನ್ನು resolve ಮಾಡಿದಾಗ horizontal component E plus Q cos theta ಆಯಿತು, vertical component E plus Q sin theta ಆಯಿತು. ಅದೇ ರೀತಿಯಲ್ಲಿ if I resolve E minus Q into its perpendicular components, then the horizontal component is E minus Q cos theta and the vertical component is E minus Q sin theta. Now here we can observe E plus Q and E minus Q both are having the same magnitude 1 by 4 pi epsilon naught Q by r square minus a square. Magnitude is same but the directions are opposite. E plus Q sin theta ಮೇಲಿದೆ, E minus Q sin theta ಕೆಳಗಿದೆ. Since they are opposite, they will cancel each other. ಈ ಎರಡು ಕ್ವಾಂಟಿಟಿಗಳು ನಾರ್ಮಲ್ ಕಾಂಪೊನೆಂಟ್ ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ. Then E plus Q cos theta ಮತ್ತೆ E minus Q cos theta gives the value of the net electric field. Net electric field ಅನ್ನ E plus Q cos theta ಮತ್ತೆ E minus Q cos theta ಕೊಡುತ್ತೆ. ಎರಡು ಕೂಡ ಸೇಮ್ ಡೈರೆಕ್ಷನ್ ಇರೋದ್ರಿಂದ the net electric field will be E plus Q cos theta plus E minus Q cos theta. ಇದು ಕೂಡ ವೆಕ್ಟರ್ ಸಮೇಷನ್ ಆಗುತ್ತೆ. R is equal to square root of a square plus b square plus 2ab cos theta. ಥೀಟಾ ಅಂದ್ರೆ ಈ ಎರಡು E plus Q cos theta ಮತ್ತು E minus Q cos theta ಗಳ ನಡುವಿನ ಡೈರೆಕ್ಷನ್ 0 ಆಗೋದ್ರಿಂದ ಅಲ್ಲಿ cos ವ್ಯಾಲ್ಯೂ 1 ಆಗುತ್ತೆ. a square plus b square plus 2ab is nothing but a plus b whole square. square root ತೆಗೆದಾಗ ರಿಸಲ್ಟೆಂಟ್ is a plus b ಆಗುತ್ತೆ. ಆ ರಿಸಲ್ಟೆಂಟ್ ಅನ್ನು ನಾವು ಇಲ್ಲಿ ತಗೊಂಡಿದ್ವಿ. E plus Q cos theta plus E minus Q cos theta is the net electric field. ಇವಾಗ ಈ E plus Q ಮತ್ತು E minus Q ವ್ಯಾಲ್ಯೂಸ್ ಅನ್ನು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡೋಣ. If we substitute the value of E plus Q and E minus Q, 1 by 4 pi epsilon naught Q by r square plus a square cos theta plus 1 by 4 pi epsilon naught Q by r square plus a square cos theta. ಎರಡು ಸೇಮ್ ಕ್ವಾಂಟಿಟಿಗಳನ್ನ ನಾವು ಆಡ್ ಮಾಡಿದೀವಿ. Therefore it will become twice, ಎರಡರಷ್ಟಾಯಿತು, 2 by 2 into 1 by 4 pi epsilon naught Q by r square plus a square cos theta. Now let's try to substitute the value of cos theta. Cos theta value ಅನ್ನು ಒಂಚೂರು ಕಂಡುಹಿಡಿಯೋಣ ಈ ಡಯಾಗ್ರಾಮ್ ನಿಂದ. From this diagram, what is the value of cos theta? If this is from this right angle triangle, if I take this angle as theta, then cos theta is adjacent by hypotenuse. Adjacent is a, hypotenuse square root of r square plus a square. Substitute the values. Therefore cos theta is equal to a by square root of r square plus a square. Now here r square plus a square whole power 1 ಇದೆ. ಇಲ್ಲಿ r square plus a square whole power half ಇದೆ. ಸ್ಕ್ವೇರ್ ರೂಟ್ ಅನ್ನ ಇಂಡೆಕ್ಸ್ ಕನ್ವರ್ಟ್ ಮಾಡಿದಾಗ half ಆಯಿತು. 1 plus half becomes 3 by 2. Therefore 2a into q, 2aq divided 1 by 4 pi epsilon naught, here 2aq divided by r square plus a square whole power 3 by 2. Now again if I take r is much greater than a ತುಂಬಾ ಸಣ್ಣದಿದೆ, then the square component is still smaller. a square ಇನ್ನೂ ಸಣ್ಣದಿರುತ್ತೆ. Therefore we will neglect a square. If I neglect a square, then the left is r square 1 by 4 pi epsilon naught 2aq divided by r square whole power 3 by 2. If I cancel 2 cancel ಆದರೆ we are left with 1 by 4 pi epsilon naught 2aq divided by r cube. Now what is 2aq? We know that 2aq is the dipole moment. Then replace 2aq with the dipole moment P. Then this is the expression for electric field due to a dipole on its equatorial line. Then what is the direction of this electric field? Here you can observe the net electric field is opposite to the dipole moment. Net electric field ಏನಾಗಿದೆ dipole moment ಗೆ ವಿರುದ್ಧವಾಗಿದೆ. The net electric field is opposite to dipole moment. Hence here we are representing minus sign ಅನ್ನ represent ಮಾಡ್ತಾ ಇದೀವಿ. The net electric field due to a dipole at a point on the equatorial line is opposite to the dipole moment. Hence we have learned that the electric field on the axis of a dipole is along the dipole and the electric field on the equatorial is opposite to the dipole. If we observe the magnitudes, in magnitude electric field on the axis is twice that of electric field on the equatorial. Magnitude alli axis in electric field equatorial electric field ina ಎರಡರಷ್ಟಿರುತ್ತೆ, but directionally ಇವು opposite ಆಗಿರುತ್ತೆ. These are the very important expressions what you have learned today. In the next session we will continue with some more topics on electric charge and electric field. Namaskar.